Today we'll be looking at linear regression. Our objectives will be to calculate a regression line, predict data using that regression line, and identify a correlation coefficient. So let's talk about a regression line. Assume that I've given you this data, and our task is to calculate the linear function that best fits this data. The assumption is that there may not be a perfect linear model, but I want to get as close as possible. So what I'm going to do is calculate a regression line. Sometimes you'll hear it called a best fit regression line because that's exactly what we try to do, is get the one that best fits. Now fortunately for you, we live in a day where you can actually do this computation on your calculator as opposed to manually the way that Noah and I did it when we were floating around on the boat together. So let's look at how we do this. Our steps are to first create a scatter plot for the data. Now you should remember how to create a scatter plot, and if you don't, I'll refer you back to the video where we did two variable data. Once you have your scatter plot entered, then you want to remember to turn on plot 1. I would suggest at this point that you pause the video and accomplish those two tasks. Then come back and I'll tell you what to do next. If you've done this now, you should be able to graph on your calculator and see these points. I am using a standard window, so in case yours doesn't look like mine, you may want to change so that you also are using a standard window. Then we should have exactly the same graph. Once we have this graph, we're now in a position to be ready to calculate a regression line. Our steps for that are stat, which is on the second row from the top of your calculator. Then use your right arrow to move to the right. And you should have highlighted the word calc when you do that. If you'll look down that list, you'll see the calculations your calculator can do for you. And I want you to notice that number 4 is linear regression. So we'll enter a 4 to tell it we want to do that. And then we hit enter. Your calculator should come back with something that looks like this. Now, some of you may not have these last two items right there, and if you don't worry about that. Everything else should be exactly like mine, and in a minute I'll talk to you more about those last two. But for right now, everyone should have y is equal to ax plus b, and then it tells you what a is, in this case 0.985, and it tells you what b is, which is 5.02. Now what we need to do is use the linear equation y is equal to ax plus b, where a is 0.985 and b is 5.02. So our linear function, or our line, is f of x is equal to 0.985x plus 5.02. Now let me make sure that you understand what you've calculated here. What you have got in front of you is the best fit line for the data that you have plotted. Let's look at how good that fit is. If I draw the line using my calculator, and you can do that by simply going back now and entering 0.985x plus 5.02 as y1. If you leave your stat plot on, you'll still have your points and you'll have your line. So you can see that it's a really pretty good fit here. So your calculator has calculated for you what it calls the best fit linear regression line. And it has given you the equation for that. Now, what can we use that regression line for? Well, one thing is you can actually use it to predict data. Let's say I want to estimate what the value would be if I had a 3 right here, and I want to know what that data would look like. Now, it's not sufficient to simply tell me to average 6.7 and 9.1. That's not the best data we can have. But what you could do would be tell me to calculate f of 3 using the regression line that you've just calculated. If you did that, you would get 7.975 is your answer. So what that's telling you is that right here, the best information you could possibly put in here would be to calculate 7.975 using your regression line. That's the best estimate you have for the data that would belong in that position. Now, let's go one step further and let's talk about those last two numbers that didn't show up on some of your calculators. These over here. Let's talk about how we can get those numbers to show up. First of all, your keystrokes would be second 0, which is catalog. Once you've done that, you should see a long list of catalog items. Use your arrow key to move down that list until you see the word Diagnostic on. So continue moving down until you see that. And it's going to be quite a ways, so move pretty quickly down through there. I've arrived there now, and what I want to do is I want to hit Enter. My calculator will come up and say, do you want me to turn Diagnostics on? You hit Enter one more time, and it will tell you it's done that. At this point, you could now go back to Stat, move to the right to Calc, redo your linear regression, and you should see those last two numbers come up as well. So you should have on your screen now the information that I now have on the screen on the left. And I want to talk to you now about what we call a correlation coefficient. It's the piece of data that you have right here with the R. In this case, it's 0.9966797547. Okay, you've got the big long number there, but I want you to notice that this number is pretty close to 1. Now, correlation coefficients range from -1 to +1. Let's talk a little bit about a correlation coefficient that is close to 1. What that tells you is that as the x values increase, so do the y values. And there's a correlation between that. Well, I want you to notice, if we look back at our data here, as this x gets bigger, so does y. As the x gets bigger, so does y. As the x gets bigger, so does y. Even with the one we estimated, that would be true, and also all the way over to the last one. So as the x's increase, the y values also increase. That is a positive correlation. Now, should this number be negative 0.99999, like that, then what you would see is as the x values get bigger, the y values should decrease. If you took this chart and you left the x's like they were and you reversed the y values so that right here you had 9.1 and right here you had 6.7 and here you had, well, that one would have stayed, wouldn't it, 5.3. But if you just reverse this data, what you would see would be a negative correlation. This gets bigger, this gets smaller. This gets bigger, this gets smaller. And so that's your negative correlation. And if you want to see that, you can actually do that on your calculator by simply reversing that data, calculating your linear regression, and observing your correlation coefficient. Now, whether it is a positive correlation or a negative correlation, the closer it is to 1 or to -1, the better your fit is. A correlation of 0 would not be a good fit at all. So what we're looking for are correlation coefficients that are very close either to +1 as we had here or a -1 like we've talked about. Guys, I know this is a lot of information in a very short amount of time. What I'd like for you to do now is, as soon as possible, get to your homework so that you can practice calculating a regression line. I'll see you soon. Bye-bye.